Welcome to the Major Work of Kindergarten, Part 1. In this session, we are going to look at the major work or the major standards that are involved in kindergarten, strategies for teaching these standards, and a thorough exploration of what each standard means. In the Part 1 of this presentation, we are going to focus mostly on counting and cardinality and a bit on addition and subtraction problems. In Part 2, we will continue our look at addition and subtraction problems, and then look at some base 10 concepts. In order to pause the slide at any time, you can press the up arrow on your keypad, and then to continue, you can press the down arrow. The slides will self-advance unless you press the arrow to pause. Our objectives for this presentation are to identify the major work of kindergarten, explore counting and cardinality, as well as early number concepts, look at the learning progression related to these concepts, and explore some teaching strategies. Before we take a look at strategies and activities, I wanted to discuss what major work means. DPI has suggested major standards and major clusters for every grade level. These are the foundational skills for future grades and are absolutely essential in order to be successful at that current grade level and at later grade levels. And then there are supporting or additional clusters. These are not the major work. They still need to be taught as designated in our standard course of study. However, these are not the determining factors of whether or not a child will be successful at that grade level or additional grade levels. When looking at remediation or review or filling in gaps for students, you're really going to want to make sure that you're hitting the major clusters and focusing on that major work for the grade level. At the kindergarten level, you can see that the major work is counting and cardinality, operations and algebraic thinking, and then numbers and operations within base 10. Today we're going to start by looking at counting and cardinality, and that includes knowing the counting sequence and rote counting, counting sets of objects, and then comparing sets or comparing numbers using greater than, equal to, or less than. Within the counting and cardinality cluster, there are several components. For example, students need to be able to rote count by ones and tens. They must be able to count forward from a given number. So first of all, they must be able to count forward from 0 or from 1, but they also must be able to count forward from, say, 5 and all the way up to 20, or 5 through 30. Students must be able to write their numbers through 20. It is okay if students reverse numerals, so if they're writing the 3 backwards or the 4 backwards, that is okay at the kindergarten level, but they must be able to record the numerals 1 through 20. Students must be able to demonstrate that the last number counted tells the total. So if the student is pointing this as they're counting 1, 2, 3, 4, when they point to 4, they realize that that also tells the total number of that set. Students must know that each number counted is one bigger than the last. So if a student is saying 1, 2, 3, 4, they do realize that 4 is bigger than 3. Students, when asked the question, how many, as in how many ducks are there, how many dogs are there, students should be able to count to answer that question. They should be able to compare sets using greater than, less than, or equal to, and then compare numerals 0 through 10. This is a big caution for teachers. Numbers and number relationships are the most fundamental components of mathematics. Yet because these topics are familiar to us as adults, we run the risk of underestimating the deep, rich knowledge that this strand encompasses. As children, we often had a lot of experiences playing different games where you roll a die or you flip a number card and move that many spaces. A lot of students these days don't have all of those rich experiences with numbers, so it's not a given that students will have this strong number sense that we as adults have. One area of difficulty in this strand that students typically have is the fact that understanding that when they're counting a set of objects, the last number counted in the sequence represents the total. This is a very abstract concept. To help students with this, we can always point to objects as we're counting and then draw a circle, a finger circle, around the entire set when we say 4, for example. So if we're pointing 1, 2, 3, 4, then use our finger to draw a circle around the entire set and say that's 4 objects in all. A huge concept at the kindergarten level is subitizing. This word just means instant recognition of a set. For example, when an adult rolls a die and it lands on 5, we instantly recognize that as 5. That is not a given concept for students, and we must practice that repeatedly throughout the year for students to grasp that. One way to practice subitizing is by using dot cards, and you can find these dot cards on the website on your screen. And what you would do is you would show the students a dot card for 5 seconds and then remove it and have students guess how many dots or tell how many dots were on that dot card. Then students can share strategies. Well, I saw 3 on the top row and then I saw 3 down below. I know that's 6 in all. You want to start off really simple with these dot cards and show them for a longer period of time for those students who actually do need to count. But after a while, the students should be able to get quicker and instantly recognize the sets. The best way to probably do this would be starting with the typical dots on a die. And the dot cards on this website do have the dots for 1, 2, 3, 4, 5, and 6 like you would typically see on a die. And then later on you would put more cards, more numbers together and be able to look at, now I know 4 pips or 4 dots on the die and I know 1, so how many are there in all? I know that that's 5. So using different strategies, and that would probably happen later on in the year with kindergarten. In addition to subitizing, or that instant recognition of sets, another huge concept for kindergarten is the concept of conservation. This just means that when objects are rearranged without adding to and taking away from the objects, they will have the same quantity. So for example, 5 cubes in a row has the same quantity as when you squish the cubes together and they're in a cluster. To practice this with students, we have a couple activities. One suggestion is just actually physically moving the activity or moving the objects to show students that they are staying the same, nothing's being added to, nothing's being changed, and then you would recount the objects to see that it's still the same amount. And then you could also move them again into a circle and recount the objects to see that the objects have not changed quantity, that it's still the same amount. This is a really hard concept for students, and you do need to frequently practice this. 3 different ways that students need to be able to count objects are in a cluster like we saw at the beginning of this slide, in a straight line, and in a circle. So make sure that you're building those different practices into your daily instruction. Now let's take a look at a couple activities, and after looking at these activities, I want you to think about whether they address subitizing, which is that instant recognition of sets, or conservation, which is the fact that a number doesn't change even when the set of objects is rearranged. So this is called the 10-frame sort. I would give pairs of students a baggie of little 10 frames, and again, you can find these on that same website that we referred to earlier. And then I would say, go. The students would sort the 10 frames by the number of objects, the number of dots on each 10 frame. They can either sort them into piles or sort them into cups and see how fast they can sort the 10 frames. And then you can repeat the activity over and over again to see if they could beat their previous time. So let's talk now about whether that is conservation or if that's subitizing. In my opinion, I think that would be subitizing because after lots of practice, the students should instantly recognize the number of sets or the number of dots on a 10 frame. Let's take a look at another activity. Here's another activity similar to our last one. This one is using dot cards. As I talk about this activity, think about whether this activity addresses subitizing or conservation. You would give the students dot cards and they would work in pairs to see how fast they could sort the dot cards by the number of dots on them. Again, the students can try to beat their time and repeatedly practice this activity. Now let's talk about whether this is subitizing or conservation. In my opinion, I think this one would hit both subitizing and conservation. Subitizing in the fact that students are getting repeated practice of instant recognition of a set. However, you're also getting conservation because the dot cards, several of them will have the same quantity as in the slide here. You're seeing several of these dot cards have the quantity of 6. However, the quantity is rearranged to different configurations each time. These dot cards on the website are available, I believe, for numbers 0 through 20. Over the next few slides, you're going to see activities from Partners for Mathematics Learning. It was a grant that the county had done a few years ago. On each of these slides, we focus on a different number concept. This slide here focuses on counting up and counting back. Students typically are familiar with counting forward, but they do have difficulty counting back. When you do this activity, you do not have to count all the way back down to 0 or 1. You could count down a couple and then count back up a couple to get students familiar with counting on from a given number. This activity here, blast off, is similar to the last one in that students count forward and count backwards. But however, this time they're actually using numbers of cubes to practice that one-to-one correspondence in addition to rote counting. Again, this activity asks students to count back all the way to 1 and then say blast off. However, in order to practice counting on from a given number, you might just want students to count back to 2 or 3 and then count back up. This activity requires students to practice counting sets using one-to-one correspondence. In this activity, you would give students a piece of paper and 6 or any other number of straws or toothpicks. The students would then build a design using their total number of straws or their toothpicks. This is a great example of conservation because each student has the same number of toothpicks. However, each student will end up having a different configuration. After doing this activity, I would probably do a gallery walk and encourage students to walk around and look at all the different configurations of the toothpicks or straws to build that idea of conservation. Now let's take a look at another activity that focuses on one-to-one correspondence, but it also kind of builds an early foundation for area and allows students to practice estimation. And just a side note, students should be developing estimation skills because that is something that's embedded into those practice standards for Common Core. This activity comes from Kathy Richardson from her book Developing Number Concepts, which is a great book for kindergarten. In this activity, you would give students a shape card and then have students estimate the number of cubes that would fit on their shape. Once the student estimates the number of cubes, then they could actually fill the cubes or fill the shape and check their estimation using one-to-one correspondence. The more shape cards students practice with, the better they develop their estimation skills and the more practice they will get with one-to-one correspondence. In addition to counting sets and rote counting, counting and cardinality asks students to use terms such as more, less, and equal to. This is a very complex and abstract concept for kindergartners, so we do need to use a variety of manipulatives and a variety of strategies for teaching this concept. One strategy for understanding which set has more or which set has less, or comparing sets, is to do a takeaway strategy. Students take away one chip from each set at the same time until only one set has chips left. This would tell students that a set of 5 has more than a set of 4. Another way to practice this is by matching the sets. So you can make a straight row of the first set and then a straight row of the second set and see that this yellow set of 5 has more than the red set, or the red set is less than the yellow set. Another great tool to use in kindergarten is the number line. When talking about more or less and equal to, you can use the number line to compare numbers by having students put a chip on a number, for example the number 3, and then finding numbers that are more than or greater than this number. So for example the number 4 and the number 5 are greater than 3. You could also have students find numbers that are less than 3, for example 2 and 1 are less than 3, or numbers that are equal to 3. It's really important that we use the number line at the kindergarten level. Common Core emphasizes the number line at every grade level. If we can start building it into what we do in kindergarten, this will lay a foundation for future grades. Another great tool for kindergarten is a 10 frame. We use 10 frames throughout kindergarten for decomposing 10s, even decomposing 5s, or modeling addition and subtraction situations. With this activity, you could practice more or less and equal to by asking students to build a set, for example, a set of 4, and then asking them to build a set that is more than their original set, less than their original set, or equal to their original set. Another activity using 10 frames, and these are the little 10 frames from an earlier activity. You would give students a pile of 10 frames, ask them to pick a 10 frame, any 10 frame, and then find another 10 frame that is more than their 10 frame, another 10 frame that is less than their 10 frame, and then one that is equal to their 10 frame. You could also have word cards that say more, less, and equal to, and the students could match those to their 10 frames. Another activity is, again, using those dot cards and just repeating the 10 frame activity that we just talked about in the last slide, but this time using those dot cards. And again, this just develops that subitizing and that conservation as we talk about more, less, and equal to. This website, illustrativemathematics.org or illustrativemathematics.org, gives several examples of tasks that you can give to your students for every grade level. If you go to this website, you would click on the grade level that you're looking for, and then click on the standard. And here is a sample task for comparing numbers that is on this website. In addition to the task, it gives sample strategies that the students may have used, and sample teaching points that you could use after providing the task to students. So now we've finished talking about the major work of counting and cardinality for kindergarten. The next piece of major work that we're going to be looking at is operations in algebraic thinking. This concept includes understanding addition as putting together and adding to, and understanding subtraction as taking apart and taking from. In this Part 1 presentation, we are only going to look at beginning concepts that you would be working on with students during the first half of the year. In Part 2 of this presentation, we are going to be looking at some later concepts related to decomposing quantities or composing quantities. There are 4 different types of problems students at the kindergarten level should be exposed to. The first 2 types of problems require an action. Let's take a look at the first type of problem. This is called add to. This is where you have 2 sets and you're adding them together, and there is an action involved. Let's take a look at what this means. Here's a sample problem. 2 cats are in the park. 2 more cats go to the park. How many cats are in the park now? You will notice in this problem there was an action of actually adding the 2 sets of cats together. 2 more cats came to the park. That was an action. Let's take a look at another problem type. This problem also requires an action. This problem type is called take from. Let's explore this. 6 dogs play in the park. 2 dogs go home. How many dogs still play in the park? And here you can see the action of taking from the original set. For these 2 types of problems, these are the types of problems that students should initially be exposed to. These are very basic types of problems. Students should be exposed to building sets, moving the sets together, or building one set and removing a set from that original set, and then counting to see the new total. We'll explore strategies for these in a minute. Let's take a look at some other problem types. The next 2 types of problems that we're going to look at require no action, and they're called put-together take-apart problems. Really, you're not adding to the set, you're not taking away from the set, you're just looking at the parts of the set. And with this first problem that we're looking at the parts of the set, the total is what is unknown. Let's take a look at a problem. It says there are 3 yellow ducks and 1 white duck in the pond. So as you can see here, you're not adding to the set, you're not taking away from it. They're just talking about the 2 different parts of the set as yellow ducks and white ducks. And then the question asks, how many ducks are in the pond? So you know that there's 3 yellow and 1 white duck. And you're figuring out the unknown total. Notice, like I said, there is no action in this type of problem. This problem is a bit more complex than the other problems because students can easily physically move sets to either find a total or to find the difference in the previous types of problems that require an action. These problems are more complex, so we probably will need to focus a bit on these problems for students to understand them. Let's take a look at another problem that requires no action. Here's another type of put-together, take-apart problem. And this time, the addend is unknown, or one part of the entire set is unknown. Let's look at the problem. 4 ducks swim in the pond. One is white, and the rest are yellow. How many ducks are yellow? And this just took the problem to a whole new level because we know the total, we know one part, we don't know the other part. This is very complex for kindergarten students. We will not be getting into these problems initially. These are going to be problems that you will build in throughout the year as students become more familiar with problem solving. We're going to explore next a couple strategies for solving these different types of problems. Here are some strategies for solving addition and subtraction problems, either with or without an action. The first way is you can act it out using students or objects, and this lends itself really nicely to the ones that require an action. You can model the problem with manipulatives or blocks or stickers or counters. You could draw a picture. Students can count on their fingers. And because for the most part students only work with numbers through 10, fingers lend themselves perfectly to solve any of these problems. You can use break-apart sticks or a math mountain. And over the next couple of slides, we'll talk about what break-apart sticks and math mountains are. Let's go back to looking at modeling a problem with manipulatives. Let's revisit that problem about the cats. It says 2 cats are in the park. 2 more cats go to the park. How many cats are in the park now? This is the most basic type of problem solving, and this is what we're going to be expecting students to do towards the beginning of kindergarten. So students should be able to model the first set of cats, and then model the second set of cats, and then put both sets together and recount to see their new whole. This can also be built into those lessons that you're just doing counting of sets, because then we can take it to the next level and do some problem solving. Let's look at draw a picture. 2 cats are in the park. 2 more cats go to the park. How many cats are in the park now? And again, this is another nice way where the students can count both sets and then put them together and count that whole set. This is reinforcing that one-to-one correspondence and that rote counting. Okay, so here's break-apart sticks. This is one that you're probably going to want to do when the addend is unknown, and this is one that you might not want to start off with at the beginning of the year. At the beginning of the year, you're really going to want to focus on objects, manipulatives, or really acting out the situation using students or using objects. Let's take a look at a sample problem for break-apart sticks. It says, 4 ducks are swimming in the pond. 1 is white, and the rest are yellow. How many ducks are yellow? So at this point, we've modeled that there's 4 ducks in the pond. We know 1 is white, so we're going to use our break-apart stick to break apart the 1 from the rest of the set. To find out how many ducks are yellow, we count 1, 2, 3. There are 3 ducks on the other side of the break-apart stick, and those are our yellow ducks. Here's that same problem using a math mountain. With a math mountain, you show the total at the top of the mountain, and then the parts at the sides or bottom of the mountain. Let's take a look at this problem. 4 ducks swim in the pond. 1 is white, and the rest are yellow. How many ducks are yellow? At the kindergarten level, we're going to use counters or chips on our math mountain. So we just modeled 4 ducks are swimming in the pond. Move 1 to the side for the one that is white. Move the rest to the other side because the rest are yellow. How many ducks are yellow? We're seeing that 3 ducks are yellow. At the first grade, second grade level, or later levels, when we use math mountains, typically students will record a numeral in the math mountain, so they would have recorded 4 at the top, and then 1 and 3 at the bottoms. If students are ready for this at the kindergarten level, they can, but for the most part, we will just be using objects on our math mountain. Let's take a look at another math mountain. 6 dogs play in the park. 2 dogs go home. How many dogs still play in the park? Well, we know our whole amount is 6, so we really want to emphasize the fact that our whole or total amount always goes at the top of our math mountain. To find how many dogs are still in the park, we would take away 2 that went home, and we would see that 4 dogs are still left in the park. And of course, this is one of those problems that requires an action, and we are physically moving the parts to show that action. Let's take a look at another problem. 2 cats are in the park. 2 more cats go to the park. How many cats are in the park now? So now we know our parts, but we don't know our whole. To get our whole, we're physically going to move all of our chips to make the whole, and we see that 4 cats are in the park. As we wrap up this presentation, I just wanted to emphasize the importance of the North Carolina DPI unpacking document. This unpacking document is the go-to document or go-to resource for planning instruction. This document outlines everything that is to be included when teaching a standard. It gives sample language, it gives sample problems, and end of quarter or end of year expectations for that standard. Here's the most important thing. If something is not included in the unpacking document, do not teach it. A lot of times teachers are trying to teach quick tricks or extra strategies that really aren't directly related to a standard. And that's what's causing teachers to end up going a mile wide, an inch deep, and not exploring to the depth that they need to. To hear more about the major work of kindergarten, please go ahead and watch the part 2 of the major work presentation. Thank you.